Morning students. So in previous lecture we have studied about the image formation by the convex lens. So basically there are different cases when we put object at different distance from the optical center. So image form at the different location. So for example, when we put object beyond the 2f1, then image form between f2 and 2f2. So next time what we do, we put object at 2f1 and where image form at 2f2. So that image are what same size and also nature of that image what is real and inverted. However, size of the image is same. And when we put object between 2f1 and f1, then where image form beyond the 2f2 and size of the image becomes large. So this is the example when we put object at f1. So when we put object at f1, so there are two rays are generated. One rays go parallel to the principal axis, and which rays go parallel to the principal axis, it pass through the focus. And second ray that pass through the optical center and that pass through straight without any deviations. So these two rays are parallel and these rays are cut at the infinity. Okay, so where image form at the infinity. So this is the case where size of the objects small and size of the image is highly large. Second, image form what is real and inverted, and what is the location of image at the infinity. So these parameters given here: position of object at f1, image of object at infinity, and size highly enlarged, and nature real and inverted. And in next case, we put object between f1 and O. So this is case. So here we put where object at here. So this is the point between f1 and O. So when we put object here, what happened? Here two rays are generated. This is first ray. So this ray parallel, so that ray parallel after refraction, it pass through the focus. And second ray, which pass through the optical center, that pass through without any deviation. So these are parallel, these are moving for each other. So these are never cut at any point. So we extend their image. So their extend image, we are cut beyond the 2f1. So this is the point. Here this cut and image form beyond the 2f1. So position of object between f1 and O, and position of image beyond the 2f1, and size highly enlarged, and nature virtual and erect. So in next we study about the image formation by the concave lens. So image formed by concave lens. Okay. So here take so this is a concave lens and this is optical center, and we take here principal axis. So this is a principal line, and this is what f1, and this is what is 2f1, and this what f2, and this what is 2f2, and this is what is optical center. So Here we take a two parallel rays which are coming from the object, and we consider here where object put at the infinitive. So first ray like this and second ray this. So this is the first incident ray, that coming parallel to the principal axis, and they diverge in different direction like this and this. So they are diverge each other. So there are no intersection point of these rays. So what happened here? So we draw that we extend this line in backward direction. So we extend these lines like this. So these extend line cut at F1. So what is the position of image? What at the focus at the F1. So here we write that parameter. So first position of object. So this is where infinity. Okay, and second, what is the location of image? So position of image so this position of image where at the F1, at F1, and what is here nature? This nature what is? Virtual and erect. Virtual and erect. And what is size? That is highly diminished. Diminished or a point size. Okay, so these are the characteristics of a concave lens when object put at the infinitive distance. Okay, so in next case, we put object anywhere from the optical center. So we find out where the image form. So we take a lens this is optical center and this is principal axis, this is F1, this is 2F1, this is F2 and this is 2F2. So here we put object at anywhere beyond the O and find out the location of a image. So basically we take a object here okay. So here first ray generated, this is parallel ray. So we know that parallel ray generated, so that appear to pass through the focus. So where at F1. So this is refracted in this direction, and what is their backward directions image? This. Okay. Second, we need one more ray. This is first ray. So we draw here second row that pass through the optical center. This is second ray. We write this is a AB. So this is the what is object, and this object height what? H. Okay. So see here where these two rays are cut at this point. Okay. So this is the point of an intersection. So here we find out that image. So draw here. So this A dash and B dash, this is the what is size of the image. So we write here, this is simply what? H dash. Okay. So here position of object, this is first parameter, and second position of image, third nature, and fourth size. Okay. So what is the position of an object beyond O? So beyond O is beyond optical center, and position of image where image formed between F1 and O. Between F1 and O. And what is nature? Nature is what is virtual and erect. Virtual and erect. And what is size? Small size. Okay. So these are the parameters of a concave lens when object put beyond the O. So in both case, image form is small and virtual and erect. Okay, so these are the characteristics of a concave lens, and next we study about how we take sign convention of that lens. So So here first of all, object always put where? In the left hand side. So object distance always negative. So here object always put in left hand side. So U always negative. So for example, we put object here. Okay. So this is U, so this always negative, and all distance that is left hand distance, so these are taken as negative, and right hand distance taken as positive. So these are right hand distance what positive, and these are left hand distance what negative. So object always put in the left hand side, so U always negative. And second thing, if object above the principal axis, so H taken as positive. So this is H, so H is positive, and H always positive because object always put on the principal axis. So object height always positive. So that is H. positive. However, image form real and inverted and virtual and erect. So in case of the virtual and erect, H is positive. So H is positive for virtual and erect, and H is equal to negative for real and inverted. Okay, and V may be positive and negative and depend upon the locations of the image, but here V form where in left hand side. So in this case, especially in concave lens, V is what is negative, and in case of a convex lens, in all case V is positive except last case when we put object between F1 and O and image form what is virtual and erect. So these are the sign convention, and all distance are measured from the pole. So sorry, here not pole. So here what is optical center. So all distance measured from optical center. And what is the formula of a lens formula? That is known as 1 by V minus 1 by U is equal to 1 by F. Okay, so V is image distance, U is object distance, and what is F? F is the focal length of the lens. So in this case, focal length what is negative? So for concave lens, F negative for concave and F positive for convex. Okay, so next formula, this is lens formula, and what is magnification? So magnification is equal to H dash by H. So this is height of the object and this is the object height, and in term of a V and U, M is equal to V by U. So there are two formulae in term of a height and in term of a image and object distance. So we can write H dash by H is equal to V by U. So these are the formulae that used for the find out the value of the V and U, especially in numerical cases. So here we take an example. So to solve a numerical, so what is given here? A concave lens has focal length 15 centimeter. So a concave lens given. So we make here concave lens. So this is a concave lens. This is optical center. This is F2, 2F2. This is F1. This is 2F1. So this focal length given, how much given here? 15 centimeter. So this 15 centimeter, what is the sign of that? F minus, because left hand distance taken as negative. And what more given here? At what distance should the object from the lens be placed so that it form an image at the 10 centimeter from the lens? So here what is given? V given. So V given here 10 centimeter. So this is minus n centimeter. And we have to find out what is object distance. So basically what is formula? 1 by V minus 1 by U is equal to 1 by F. So we have to find out minus 1 by minus U. So minus 1 by U is equal to 1 by F minus 1 by, take here this V. Okay. So take here negative sign common. So what you get? This implies 1 by u is equal to 1 by v minus 1 by f. So what is the value of a 1 by v? Minus 10. And what is the value of a f? So here minus and 1 by minus 15. So this minus minus plus. So this is equal to minus 1 by 10 plus 1 by 15. Okay. So take common here. So we take here 5 common. So minus 1 by 2 plus 1 by 3. And this is equal to 1 by 5 and minus 3 plus 1 by 6. So this is equal to 1 by 5 multiply by, so this becomes here 2 if we take LCM. So this is minus 1 by 6. Okay. So here this is equal to what? 1 by u. So 1 by u is equal to minus 1 by 30. So this implies u is equal to minus 30 centimeter. So what is the location of a object minus 30 centimeter? So where put object? Here. Okay. So we can also find out here magnification. So m is equal to simply m is equal to v by u. So what is v given here? So v given here minus 10 and this given minus 30. So this is equal to 1 by 3. So this is the magnification. So m is equal to 1 by 3 and sign of that is positive. Okay. So here image form what is? So in concave lens, image form always virtual and erect. So here image form virtual and erect. So what is nature? Virtual and erect. Okay, thank you very much.